Hi everyone. In this video, I'm going to go over the multiple choice section of the practice test to help prepare you for your test on Thursday. Question 1 says, an astronaut has a mass of 82 kilograms on Earth. He travels to outer space where there is no gravity. Determine his mass and his weight. Before I select my answer, I'm going to fill in this justify your answer column with some facts that I know about mass and weight. So I know that mass stays the same no matter where you are in the universe, meaning it's not dependent on gravity. So if I'm on Earth, if I'm on the moon, if I'm in outer space, my mass will not change. And I also know that weight does depend on the force of gravity. A better way to say that maybe is that weight is the force of gravity. And for those two reasons, I'm going to be selecting choice A. So the astronaut's mass should not change. It should still be 82 kilograms. And since weight is also the force of gravity, if there is no gravity, there is no force of gravity. And that's why his weight is 0 newtons. Question 2 says, a test booklet is sitting at rest on a desk. Compared to the magnitude of the force of the booklet on the desk, the magnitude of the force of the desk on the booklet is the same, greater, or less. Again, before I select my answer, I'm going to justify what I know about this problem. I immediately recognize this as a Newton's third law problem. And I know it's a Newton's third law problem because it's between two objects. My two objects are the booklet and the desk. And they're asking me about a force, so I'm just going to write it's related to forces. So that's kind of how I recognize a Newton's third law problem. It's two objects, the booklet and the desk, and they start by talking about the force of the booklet on the desk, but then they switch the objects. They say the desk on the booklet. So when they switch the objects, that's another sign that we're looking at a Newton's third law problem. The whole point of Newton's third law is that the forces are equal. So right away, I kind of know it's going to be choice A. The forces are the same because that's the whole point of Newton's third law. If I wanted to go a little bit further, I could look at the action and the reaction. I could say that the action is the booklet pushes down on the desk. And I could say that the reaction, the desk pushes up on the booklet. In the physics Regents, they don't typically ask you to go that deep. They will just ask you to determine the magnitude of the force, and it's always going to be the same. So my answer is choice A here. Question 3 says, a 65 kilogram astronaut weighs 638 newtons at the surface of Earth. What is the mass of the astronaut at the surface of the moon, where the acceleration due to gravity is 1.62 meters per second squared? I'm going to use the same fact that I already know about mass that I used for the first question. I know that mass does not change depending on where I am in the universe. So I'm just going to copy that here. Mass stays the same no matter where you are in the universe. And for that reason, a 65 kilogram astronaut will still be 65 kilograms on the moon. Question 4 says a 12th grader and a 6th grader are playing tug of war. The force that the 12th grader exerts on the 6th grader is equal to 40 newtons. The force that the 6th grader exerts on the 12th grader, and then we have these 4 choices. This is a Newton's third law problem again. And the reasoning is still the same. It's two objects, the 12th grader and the 6th grader, and they're exerting forces on each other. We can even see that the order switches again. So they say the force that the 12th grader exerts on the 6th grader, and now they're saying the 6th grader exerts on the 12th grader. So it's another sign, again, that it's a Newton's third law problem. Once I know it's a Newton's third law, I should just be picking the exact same force. It must be equal to 40 newtons because they already told me the force is 40 newtons. There's no surprises there, no changes, just force will be the same. Question 5, which object has the greatest inertia? To justify my answer, I need to know what inertia is. Inertia is mass. It's going to be measured in kilograms. So inertia does not depend on these meters per second that are given to me. Traveling at 90 meters per second, 10 meters per second, none of these velocities or speeds matter. I'm just looking at the kilograms. The greatest inertia is the one with the greatest number of kilograms. In other words, the greatest mass. And that's why I picked D as my answer. Question 6. Which situation represents a person in equilibrium? So we do have a lot of notes on equilibrium. But some key things that we know about equilibrium are that it involves balanced forces, constant velocity, and no acceleration. So to answer the question, a child gaining speed, that's a type of acceleration. We can't have that. A woman accelerating upward, obviously acceleration. We can't have that. Standing still, that actually is a type of constant velocity. It's just a zero velocity. So standing still will count as equilibrium. And then the last one, a teenager driving around a corner. That one's kind of tricky because you have to remember that turning counts as acceleration. Question 7. A constant eastward horizontal force of 70 newtons is applied to a 20 kilogram crate moving toward the east on a level floor. If the frictional force on the crate has a magnitude of 10 newtons, what is the magnitude of the crate's acceleration? In this case, we are going to be doing a calculation. I'm choosing the formula F net equals ma because I'm being asked for the acceleration and I actually was given two forces. So I'm going to have to kind of combine them together and remember how to calculate net force before I can solve this question. I decided to list out my variables. To find F net, I kind of have to know that my 70 newtons is applied. So that's going to be going one way. And then my frictional force of 10 newtons is going to be going in the opposite direction. So I need to remember that my net force is going to be 70 newtons minus 10 newtons, or 60 newtons. And if I wanted to draw a picture of it, it could look something like this. Applied force of 70 newtons to the right, and a force of friction of 10 newtons to the left. Subtracting those two forces is how I end up with 60 newtons as my net force. They told me my mass was 20 kilograms, and I'm solving for acceleration. So I can just write 60 newtons equals 20 kilograms times acceleration. To get acceleration by itself, I want to undo this 20 kilograms that's in the way. Right now, it's being multiplied by acceleration, so I want to divide it. So I could do 60 newtons divided by 20 kilograms, and divide it by 20 kilograms on both sides. That would give me 3 meters per second squared is equal to my acceleration once this 20 kilograms cancels out. And so that's how I get C, 3 meters per second squared. Since this is a multiple choice, you're not expected to show your work for this type of problem, but it's good to still have this as a strategy. Question 8. Which situation describes an object that has no unbalanced force acting on it? No unbalanced force is kind of a long way to say equilibrium. And we can look at the same notes that we made on equilibrium. It means balanced forces, constant velocity, and no acceleration. So they're asking for an object in equilibrium. An apple in free fall, that's accelerating. A satellite orbiting the Earth, that's something that's turning, which is a form of acceleration. We're really looking for these keywords, constant velocity. That's going to be our answer, a hockey puck moving at constant velocity across the ice. The last one, choice D, a laboratory cart moving down a frictionless 30-degree incline is going to be speeding up as it slides down that incline. Question 9. The magnitude of the net force acting on the object is what? So this was the exit ticket from one of our classes. You need to remember that the net force can be found in a few different ways. So it can be found by using addition, subtraction, or in this case, we're going to be using a squared plus b squared equals c squared. So that's when the forces are perpendicular. We'll be using this formula. This is another case where you don't have to show your work, but it can definitely help. I plugged in 4 and 3 as my A and B. If I put this into my calculator, I'll get 25 equals c squared. And that is an answer choice, but I need to remember to do that last step and take the square root of both sides. That will give me 5 as my answer, so 5 newtons is what I'm going to choose. The last multiple choice question, number 10. The graph to the right represents the relationship between the force applied to a spring and the spring extension for a certain spring. A greater slope would correspond to what? I'm going to start by writing down that the slope of this graph equals the spring constant. And we learned that when we were doing our spring constant lab. So if the slope is the spring constant, a greater slope must then mean a higher spring constant.